Welcome to the third of a series of videos on how to solve trig equations. In this video we'll talk about how to solve trig equations that require the use of identities, how to solve trig equations that are not factorable, and also how to solve trig equations by squaring both sides. So the first two videos are pretty straightforward. Now we're going to see some more challenging problems. On this first problem we want to solve the equation on the interval from 0 to 360 degrees. And we have cosine squared x minus sine squared x equals 1/2. Normally when we can write an equation in terms of one trig function, that's very helpful. So remember the identity sine squared x plus cosine squared x equals 1. We have to make a choice whether we want to substitute an expression in for cosine squared x or sine squared x. And in many cases there's more than one way to do this, but I'm going to replace sine squared x with 1 minus cosine squared x. And since we're subtracting sine squared x, we must subtract the quantity 1 minus cosine squared x. Now let's go ahead and clear these parentheses. Notice we'll have minus 1 and then also plus cosine squared x. So we'll end up having 2 cosine squared x minus 1 equals 1/2. Next we'll isolate the cosine squared x, so we'll add 1 to both sides. 1/2 plus 1 would be 3/2. And now we'll divide by 2 or multiply by 1/2. So we have cosine squared x equals 3/4. Now we'll square root both sides of the equation. So we have cosine x equals plus or minus the square root of 3 over 2. Now this ratio should remind us of a 30, 60, 90 right triangle, where the cosine of a 30-degree angle is equal to square root 3 over 2, which tells us our reference angle will be 30 degrees. And because the cosine function value is plus or minus square root 3 over 2, we are going to have to sketch a 30-degree reference angle in each quadrant to determine all of the angles that will produce this cosine function value. So let's go ahead and do that. Let's go ahead and label all of the sides of each triangle. Notice that each of these angles would have a cosine function value of plus or minus square root 3. So let's go ahead and figure out what all these angles would be. There's 30 degrees. The next angle would be 180 minus 30, or 150 degrees. The third angle would be 180 plus 30, that's 210. And lastly, this angle here would be 360 minus 30, or 330 degrees. Let's go ahead and check this on the graphing calculator. What we can do is type the left side of the equation into y1 and the right side into y2, and then use the table feature to check. So what we'll do now is make sure that y1 and y2 are equal at these values of x. Let's make sure we're in degree mode, which we are. So now we'll go to our table, second graph. Let's also make sure that we have our table on the ask option. So we'll go down to the independent variable, make sure it's on ask, which it is, press second graph, and now we'll type in what we think the solutions are. And it all looks good because y1 is equal to y2 for these x values. Let's go ahead and try another problem. Now for this problem there's no obvious substitution. However, this should remind us of the identity tan squared theta plus 1 equals secant squared theta. So what we can do here is actually square both sides of the equation, and when we do that we will obtain a tan squared theta and also a secant squared theta, and then we can use this identity to perform a substitution. So let's go ahead and try that. We'll square both sides. Now we'd actually have to FOIL this out. The result would be tan squared theta plus 2 square root 3 tan theta plus 3. Now remember, this middle term came from FOILing this out. We should write this out twice and then FOIL it. Now to get this equation in terms of just tangent, we can now replace secant squared theta with tan squared theta plus 1. So we'll do a substitution here. And now that we have everything in terms of tangent, we can see that if we subtract tan squared theta from both sides, these two terms will be eliminated. So now we can solve this equation for tan theta. So the first step would be to subtract 3 on both sides. So we'd have 2 square root 3 tangent theta equals negative 2 divided by 2 square root 3. So we're left with tangent theta equals, this simplifies to negative 1 over square root 3. So we're looking for the angles that have a tangent function value of negative 1 over square root 3. Again, this should remind us of a 30, 60, 90 right triangle. If you take a look at a 30-degree angle, the tangent of this angle would be 1 over square root 3. Since we have a negative function value, we know that tangent is negative in the second and fourth quadrant. So what we'll do is we'll sketch a 30-degree reference angle in the second and fourth quadrant to figure out what angles. So this first angle looks like it would be 150 degrees, and the second solution looks like it would be 360 minus 30, or 330 degrees. Now they do ask for the angles to be in radians, so 150 degrees would be 5 pi 6 radians, and 330 degrees would be 11 pi 6 radians. Now we have to be careful here. When you square both sides of an equation, sometimes you get extraneous solutions, which are solutions that may appear as solutions, but they don't actually work in the original equation. So let's go ahead and check these like we did on number 1. So we'll type the left side in y1, and then in y2 we'll type secant x. There's no secant key, so we'll type in 1 over cosine x. Go to our table and we'll type in what we think our solutions are. I'm already in degree mode, so I'm going to type in 150 and 330. What we'll notice here is that 150 degrees, y1 and y2 are opposites, so they're not equal. So 150 degrees is not a solution. And notice that 330 degrees does check. So it is important that we check our solutions when we square both sides of an equation. This is not a solution. We have one solution, which is 11 pi over 6, or 330 degrees. Okay, I think we have time for one more. So there's two possible substitutions we could do here. We could try to replace sine squared x with 1 minus cosine squared x, but then we still have this double angle. So we're going to go ahead and replace cosine 2x with cosine squared x minus sine squared x and see where that leads us. And this does help out because notice we have minus sine squared x plus sine squared x. So those add to 0, and we're left with cosine squared x minus 3 cosine x equals 1. Looks like it's in quadratic form, so let's go ahead and set it equal to 0. Now the other problems that we've seen, this was always factorable. But now we've come across one that's in quadratic form but not factorable. So we're going to have to use the quadratic formula to find the possible solutions for this, where our a value will equal 1, b equals negative 3, and c equals negative 1. The difference here is instead of saying x equals, we're going to have cosine x equals negative b, or negative negative 3, plus or minus the square root of b squared minus 4ac all over 2 times a. And this will simplify to 3 plus or minus the square root of 9 plus 4 square root of 13 all over 2. Let's go ahead and find the decimal approximations of these two values. 3 plus the square root of 13 divided by 2 is approximately 3.3028, and 3 minus the square root of 13 divided by 2 is approximately negative 0.3028. The first thing we should recognize is that the range for cosine x is the closed interval from negative 1 to positive 1. So this will not give us any possible solutions for x. Let's take a closer look at this one on the next screen. What we can do now is take the inverse cosine of both sides. So on the left side we'll have x. On the right side we'll go to our calculator. And this gives us approximately 107.6 degrees. Sketch this angle on the coordinate plane. So we'd have 90 plus another 17.6 degrees. Now notice that means that our reference angle here would be 180 minus 107.6, or 72.4 degrees. The reason that's important is because remember that cosine is negative in both the second and the third quadrant. So there's another angle that has the same cosine function value in the third quadrant with the same reference angle. So if we sketch another reference angle of 72.4 degrees in this quadrant, this angle here will be another solution to this equation. So we'd have 180 plus 72.4 which is approximately 252.4 degrees. I hope you found this video helpful.